Okay, thank you, George. So my name is Masahiro Fujita from Intelligent Dynamics Laboratory. We change very often our laboratory's name of Sony Corporation. Okay, this is the outline of my talk today. So let me first explain about what is the robot entertainment, followed by the SDR, small humanoid. Okay, in short, the progress of the computer technology is very rapidly and still continued. So the question when we started our project in 1993, what is the next technology using the computer technology? So our answer is the autonomous robot, such as the R2-D2 or C-3PO in a movie of the Star Wars, and the Astro Boy or Doraemon is a famous cartoon hero in Japan, and also the other, the heroine or hero in a science fiction movie. But we know there is a very big technology gap to realize these autonomous robots. So our answer to approach this is to focus on the entertainment, because the most difficulty to realize these R2-D2 robot is it's a difficulty to realize the perception technology or control technology in real world, in real time. Also, the most difficulty is to achieve a safety and reliable in a home environment. But think about the entertainment application. For example, if we can build a small, this size robot, if this robot is falling down, so this is not so big problem. Also, if we think of the pet-type robot, and then pet-type robot misrecognize its owners, it's not so serious problem. So we think the focus on the entertainment is a good way to make a bridge over this technology gap, so that we can accumulate technologies and then finally realize this autonomous robot. This is our motivation why we start with the entertainment robot. And this is the example of the prototype which we made an announcement in 1997. So we put artificial emotion. So in this case, if the human pets his head, the robot feels pleasant, then go to the sleep. Okay, we have been developing various types of robot, such as the Aibo. This is the first generation of the Aibo, and this is the second generation. This is the latte and the macaron. We also built this small humanoid robot. And then we came up with the idea of the OpenNow, which is a kind of standard architecture and a set of the definition of the interface, because we have to develop many applications for the entertainment robot, such as pet-type robot, game robot, or dancing and singing robot. Also, we have to develop various styles of the robot, such as the code-wrap type robot, wheel-based robot, or humanoid robot. Also, in terms of the system architecture, the pet-type robot is better to be a standalone system, which include everything, CPU and battery. But for the control robot, maybe we need a remote control system to control the robot. Also, if we think of the connecting the network, internet, then system must be somehow handle this network protocols. So to implement these various style of the robot and various applications, we think it's better to develop a reusable component in terms of the hardware and software, so that we can combine these component to build various style of robot and various applications, and also the various systems. So this is the idea of the OpenNow. And then we would like to build an OpenNow community where various people, many field of the people, can join and share the technologies. For example, in a SIGGRAPH, I think many researchers from university or a software company, as well as the device company, is here. So, for example, researcher can use the robot as a platform to develop a new algorithm or new technology, and then software company can use this kind of technology to build the product. Also, I realized there are many artists here, so artists can create, for example, motions of the robot, or sound or song of the robot. So I will explain later. The artist is a very important role in this community. But to build this community is one of the aim of proposing the Open Now. Now, last year we made an announcement to open the Open Now SDK for Aibo. So please visit this website, www.opennow.org. It's misspelled, org, so that you can find how to get this SDK for free, and also you can learn how to program for the Aibo. Okay, now let's move on to the SDR. Then let me start with a very simple question: why humanoid? Dr. Ambrose also said, why does NASA going to the humanoid? But basically, some people said the humanoid is very good test bed for human science research. It is said as a constructive approach for these people. Other people say humanoid configuration is best configuration for human living environment, because this environment is basically designed for the humans. So human configuration with human size is the best for the robot configuration. But I'd like to add a third reason, which is the humanoid or robot. Basically, robot can be a new media for communications and motion entertainment. To explain these reasons, let me introduce very interesting discovery in brain science, which is called mirror neurons. Basically, this is found in the monkey's brains, but recently it is found also in the human brain. So when you watch the other person's motions like this, what happens in your brain is the particular part which is used when you do the similar motion is activated. So only watching this, the other person's motions, your brain is simulate the real motions by yourself. So my question is, then what happens if you watch the humanoid motions? So this is the experiment for this about 3,000 people here. So please put your hand on your head and feel your mirror neurons activity. Let's stop here. So I think you can feel your mirror neurons activities. Thank you. At least you can understand what this is SDR-4X doing like this. This means actually you can realize what is the motion of the humanoid is. This is very important feature of the humanoid. So this cannot be happen if we make a similar motion with non-humanoid type robot. So the important thing is if a humanoid interacts with a human with its body emotions, activity of human brain might be essentially different from the activity when interact with the other type of robot. So this is the reason why I think of the humanoid is very important. Now let me explain about SDR-4X and the 4X2. So last year in 2002, we made announcement of the development of SDR-4X, this one. And then this year, we made an announcement of the SDR-4X2, which is the improved version of the SDR-4X. So basically, this is the basic configuration of the SDR-4X2. The height is about 60 centimeters, weight are about 7 kilograms, and it has the 38 degree of freedom, including the 10 fingers. And this is the basic hardware specification. We use the 3 CPU with the MIPS architecture, about 4 megahertz CPU clock, and also acceleration meter sensors, also the angular rate sensors, so various kinds of sensors we use. For the SDR-4X2, because we improved the safety features, we put pinch sensors for each joint so that the SDR can detect if your finger is pinched. So I would like to start the demonstration, but let me start with some key technologies. The first one is real-time motion control technology, which is the real-time gating pattern generation with balancing, of course. And also falling down and recover motion control. SDR, when SDR is going to falling down, it protects by itself to using the arms or to make the motions. Also, the real-time spatial perception technology. Using the stereo camera, the SDR can measure the distance from the obstacles. So actually, he can avoid the obstacles. And also using the multi-microphone, 7 microphone, in fact, he can recognize the direction of the sound source. And finally, the third one is the multimodal interaction technology. So SDR can detect the face, human face, and identify its face, and also learning the face through the interaction. He also recognizes speaker identification with his speech. And the main application of SDR-4X is the dialogue, entertainment dialogue. So we implement large vocabulary continuous speech recognition for about 20,000 words, so that we can implement very simple entertainment dialogue. So to integrate all these technologies, we develop autonomous behavior control architecture, including dialogue control. So I'd like to start the demonstration. Okay. So first one is the we call soccer boy. So using the color camera, he can detect a pink ball, and then close to the pink ball and kick it. SDR, track the pink ball. Oh. Hey. Okay, then the next one is the landmark navigation. So using the color detection technologies, SDR can recognize the landmark and to detect its position. So in this demonstration, SDR can detect the obstacles, which is the white stuff. Then he tried to go straight forward about 1.5 meters to avoiding these white obstacles. You can see this is called occupancy grid. So white part is the floor and black part is the obstacles. So he tried to go over the obstacles to avoiding the obstacles. So he sometimes changed his path. This is real-time computation. And you can see the SDR can detect the color landmark Now it has the 3 landmarks detected.
Don't worry if you can't hear him. He only speaks Japanese.
What he's talking is because each landmark is corresponding to the countries. So I'm not sure. He tried to visit some countries, let's say America, then he's talking about Americas. So America is such a great country or something like that. Okay. So he now visiting the next target, which is he already recognized as the position of its landmark. This is Senegal. I don't know where the Senegal is. Okay, so now he's reached at the Senegal. And he realized he reached. He says he cannot see the applause. Okay, the third one is the is the clapping hand. Okay, because as I explained, he has the 7 microphone in his head. Using this multi-microphone, he can detect the sound source. Also, he detects the motion of the image. So now, he is clapping his hand, and then SDR can detect the sound source. So now another person is clapping his hand, and then he can recognize his sound source, and then Thank you. Okay, the last one is the dancing performance. Let us put the wireless microphone for his. Actually, he generates the sounds, so it's better to to pick up the sounds for his dancing. And then this was this was composed by famous Japanese composer Ryuichi Sakamoto. There's no title, unfortunately. Thank you. Okay, let me go into. Okay, I said the humanoid must be a new media for the communication and the motion entertainment, which means nowadays the composer, the artist, compose a music, and then we can enjoy his music, composed music, using the CD player and other media players. But in the future, or near future, perhaps the artist create the motions or songs or things for the humanoid, and then we can enjoy the motion entertainment. Or sometimes the artist can compose, design the contents of the dialogue so that we can enjoy the dialogue. Could you make the sound from here? PC? From PC? This sound.
Thank you very much.
Could be the new application for the robot. And also, we think of the connecting the internet, that many contents which can be machine readable one will be developed in the future, so that we can, for example, we can ask the SDR what is the news today or what is the weather today. Then the SDR can answer these kind of questions. Okay, let me summarize. Our goal is to develop a real-world entertainment robot to establish for a new industry for autonomous robot. And then it is important to involve the people from manufacturing or software industry, researchers, as well as the artists in activities. The future is the low barrier for safety and reliability, and then we can use the wide range of the technology from low-tech and high-tech. So the important thing is the diversity of the robot's shape and applications. And then the people from the artist or software industry can generate new hardware and software component, so as well as the new contents for the robot. So why don't you return to the real world from the virtual world? So let's start with the programming Aibo with OpenR SDK. So it's again free to download from this website. Okay, thank you very much.
Thank you very much.